2021.
Pay attention to not only the instructions at the beginning of the problem, but at the very, very end of the problem.
Going on in the main gym, free to all within. Probably scheduled for about 12, 20. Your own responsibility during that time. Choose not to go for choice. Part of the time will be just the pep rally. Lunch, Domino's pizza, corn dogs, ham and turkey stuff, grilled chicken in the main line, or the grill, Domino's pizza only. Activities today at 1 o'clock. JV varsity cross country, Rapid City Heart Ranch. Again, after the pep rally, you will be back at 1 o'clock. And again, take a few minutes, depending on the length of the pep rally and all the great activities that the cheerleaders have planned for the student body. Homecoming parade begins at 1:30. Tailgate begins at 5 at Wildhair Stadium. Football game begins at 6. Homecoming dance begins at 8:30 and ends at 11. We have some activities also tomorrow. We have varsity tennis at 2. JV volleyball at Kansas County. Valley Bowl competition at Douglas.
We working on this?
Remember, for the dance tonight, playing to attend, you need to have your ID. No ID, no get in. $7 per person or $5 and 2 cans of food. We will stop printing IDs if you can't find yours at 11:30 today. Make sure you have one before that time if you need it. We plan on 10. The winner has been selected for the book club, and the books are ordered. The official title release will be for the time when the books arrive. If you're a freshman and you're interested in the world's classroom items, you received another email from Mr. Lyon this morning. Make sure you check your email. Any freshman that's interested in the world's classroom trips from the past or coming up. Yesterday's dress-up winners, you get $25 to the Green Bean. Cadence Jones, Aaron Bakeys, and Jonah Donner. Stop in the office, pick up your $25 gift card, and take your friends to the Green Bean. I'd like to thank all the students, most of all of you, all of we participated very well in the dress-up days. Did a great job. Next week, Air Force recruiter will be set up in the Commons during lunch on Tuesday. Stop by if you're interested in the Air Force. So please stand for the pledge. You do the pledge.
Of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty.
All have a great day.
We should have. That's like the best movie.
Oh, wait, we did. It was the perfect movie.
Cars is by far the best movie.
Dude, somebody is covering my head.
I take this to mean we're all done.
No, I'm not talking. I'm working. Okay.
I know everyone's all riled up today, but we only got a short amount of time, and I want to try to get something accomplished. We good? See a lot of phones scrolling, so I think we're good. First up, f times g. Well, f times g, f divided by e, g, f of g, all of them. I just take those rules and do the thing with them. Oh, wait, get back here. F rule says squared minus 6 thing plus 10. And there goes g of x. I suppose I should actually write f. Okay. Set them all up. F times g is literally just f rule times g rule, combined like terms along the way. We should have, what's that? X to the third, Frank. Okay, this is actually your fault this time, Frank. Come on. All right, so we got what? X to the third, negative 6x squared, negative 2x squared, negative 8x squared. It's going to be 10x plus 12x is 22x minus 20? Question mark? For those of you who actually wrote it out. Okay. This one, be careful. Whenever, yeah. When, we're getting there. Well, I like to talk about all the domain at once, like what's different between them. This one, you have to be careful that you're taking x minus 3. Oh, no. Back up. Let's try that again. That's not factorable because I said a minus 6 when I shouldn't have. It was supposed to be just a minus x or a plus x. Damn it. Okay. Well, ta-da! There it is. That's what it is. Well, I intended it to cancel, but can it not cancel? Yeah, that can happen. Now, y'all remember this? The zero of it. It's always the zero of it. That's a x minus 4 plus 2 over x squared minus 6x plus 10 times x minus 2. I could use that to cancel them out, but I'm guessing no one did. Yeah, the remainder is your remainder fraction at the end. But all right, we'll review that in chapter 2. But meh, I wanted it to work. I numbered wrong, so it doesn't work. That's just the answer. Down here we got x squared minus 4x minus 10x plus 4 plus 12, 16, 26? No?
You forgot a negative. Oh, wait. No, that's what I got.
That's what I got. It's negative 6x.
X squared minus 4x plus 4
No, wait, you're right.
minus 6x plus 12 plus 10.
Yeah, you're right.
You're right. I was looking at the wrong spot.
Okay. All right. So I get here, and then I have to do the whole domain business. Were there any restrictions to any of these three? Okay. This had a polynomial Polynomials have a domain of all real numbers. Polynomial, domain of all real numbers. Rational function, thou shalt not divide by 0. Negative infinity to 2. Can't touch a spanner, no. And 2 to infinity. Now, before I chisel this in stone, over here, remember, g of x was an input function. Did you go back to g of x and determine, is there a restriction to g of x?
No.
Okay, so it is still all real numbers. But we do have to check that just in case. So what we're going to say is got there, got there, got there, domain, and these didn't have any restrictions, so they're going to get lumped together. Okay. Actually, you kind of are.
Thank you. Thank you.
After grading all the quizzes, like, yeah, good job, dude.
Thank you.
Mr. Sullivan.
Hi.
On the dividing,
Uh-huh.
how did you get -2? Oh, because you have to set the equal to 0.
Set that equal to 0. Add 2, x equals 2 is what makes this 0.
Oh, got it.
Right?
Yep, we're good.
Okay. Then, beep, beep. No, not you. You. There we go. From the homie work, fouty foe. Next page. There we go. Okay. If you are beyond stuck, you can always.
We have a question.
Hi.
What if we perhaps
Miscounted and didn't do 44?
didn't do the homework?
Then just do it later. I said, I try to do enough examples and practice in class so that you have what you need. The assignment is supposed to be that 15 to 20 minute range of a little extra practice on your own without someone holding your hand.
So if I have a question on the homework because I didn't do it last night, would you answer it if I still had it?
Yeah.
Okay.
I had a kid who, last year, first semester, I think. Kid did like a total of 6 assignments the whole semester. Was sitting really good tests, but was sitting at like a 69.2. Wasn't going to be able to move on to trig. He sat in here the last day of finals and cranked out like 10 assignments. Yeah, I put him in. Okay. Now, he talked to me, we worked together. That's different than just, I'm not going to give a flying fornication and then decide to care because now the grades are in. But, no, life happens. I didn't grade anything last night. My neck hurt so bad, I couldn't be at my desk. I just laid down. Like, I couldn't do it. So, sometimes life happens. It's all good. If you want to do that, you can always do that. Okay? Now, we don't want to rely on that, but if something gets really gross, that's always your, like, escape hatch. Okay? Now, the problem here is that there's 2 ugly parts, right? So what I'll do is say f of x is both of those ugly parts, and then I'm just going to have to monkey with it until it fits. Hi?
So I said f of x
Okay. Now, I'm just going to do this. I'm going to start there, okay? I need to have something on a denominator. I need to have something in a radical, right? Like at the end. So why don't I just make that the end game? Then I got to start monkeying with it and say, well, g of x, I know that this needs to be a 2x plus 6. And I don't want to have to mess with the radical anymore. But now, if I plug that here, I'll have a 2x plus 6 instead of an x. I have twice as many x's there as I'm supposed to. So I now have to monkey with the numbers, and it's not going to be a 6 on top because I want that stuff to cancel out. What if I change this to a 12? When I plug 2x plus 6 in here, now what's going to happen? This will cancel to a 6. This will become an x. This will become a plus 3. I'm almost there. Minus 3. Well, no, that's not going to work either, right? Because then I'll have 2x plus 3 under 12. I want it to reduce down to nothing. I need a minus 6 here because I'm going to take the 2x plus 6 minus the 6, and then I'll reduce it. See, you just have to kind of pick at it until you get it to fit. That's one way. That's only one way. You could have gone ham with the radical instead. Like, there are other ways to do this. In fact, there's literally an infinite number of ways to do this. As long as you can show that the composition works, you're good. But to me, that was the ugliest part. So I make that my f of x. That one's a question every year. I was kind of surprised that no one asked it last night. I leave it there specifically so we can talk about it. 44. Yeah. Every year.
How many people have actually asked the question this year? Like, 30?
The beginning, the first like week and a half, when I was kind of making a big deal about it, it was pretty good. After that, it trailed off, which is a bummer. Something has changed in just the attitude of students in general. 4 or 5 years ago, my phone would blow up every night, 20, 30 messages. Now, I might get 5, 6 a week. Like, it's different. And that's school wide. The math department's been talking about this for years. Like, kids are just different now. Just not willing to ask. Oh. But besides 44? Okay. I'm going to get as far into 1.7 as we can. I doubt we'll get the whole thing done. But inverses. I talked about them yesterday. Let's try this again. Everyone look straightforward. I got it. Okay. I want you to raise your arm 180 degrees from its current position. I want you to lower your arm 180 degrees from its current position. Right back where it started, right? Okay. An inverse is the opposite of, where they will cancel each other out. Specifically, you saw this in geometry as reflection across the line y equals x. If I draw that dotted line y equals x, the identity, then whatever the graph is, whatever the relation is that you have to begin with, should mirror butterfly style across that axis of symmetry. This is also why that parabola, when I do its inverse, now I have a parabola on its side. That is a thing. Turns out you didn't know everything about parabolas. We will do that in chapter 7. There's a whole bunch of stuff about parabolas that I didn't tell you. We have to cut the bottom of that off to have the square root, right? Because otherwise it's not a function. And that gets us into the difference between an inverse relation versus inverse function. What's the difference between just a relation and a function? I have here the sibling machine. I pick up Aubrey and chuck her into the sibling machine. Who comes out? A bunch of different siblings, right? Because I know you got a bunch, right? I've had like 3 or 4 of them. Okay? I take that same sibling machine and I chuck Maddie in there. Nothing, right? Okay? A relation is just a rule. Think of it like the controller mapping. Okay? If I press this button, I reload. This is what it does. This button has this function. A relation maps input to output. If you throw me into the sibling relation, there is no output. Oops, I am also only child. Ma had me and was like, hell no, not again. Okay. Bring it back, bring it back. A relation is just any mapping. The input can have multiple outputs. That's okay. A function. What's special about a function? That input, that x value, that domain will only go to one element of the range. So that's why this, it's a relation, yes. Any mapping is a relation. But it's also a function because the -3 button only does one thing. The 2 button only does one thing. They might go to the same thing, and that's okay. But an inverse swaps. Output is now input, input is now output. Domain and range switch. So that's it. Just inverse relation is where your domain and range swap. You swap your domain and range. Now to be an inverse function, I do this and it's still a function. Meaning, after I swap my domain and range, every element of the domain still only goes to one in the range. So this, its inverse would be an inverse relation, but not an inverse function. Because now I press the 5 button and it does 2 different things. Yes?
So then every inverse function is an inverse relation, but not every inverse relation is an inverse function.
All thumbs are fingers, not all fingers are thumbs. Yes? Okay. So, naturally, if we had a vertical line test to tell if something's a function, well, when I swap everything, vertical becomes horizontal. So if a function is going to have an inverse, that means it'll pass a horizontal line test. Okay, so come back here to parabola. Just look at parabola. Would this pass a horizontal line test? No. That means its inverse is not a function. Because when I swap x and y, its inverse Purple one doesn't pass the vertical line test, right? Vertical and horizontal swap. So if the original passes the vertical line test as a function, passes a horizontal line test, its inverse is also a function. That's really handy because I look at a function and they say, find the inverse if it exists. The very first thing I do, check out the graph and see if it's going to pass a horizontal line test. Because if it doesn't, I just say the inverse doesn't exist. It's not an inverse function, just a relation. So, graph it on a graphing calculator, unless you just know what it looks like, and apply the horizontal line test. So the first one, what is this? Absolute value function looks like a V, right? Specifically, it's one translated 1 unit to the right. Will that pass a horizontal line test? No. So I say its inverse, should also say, the inverse looks like this. Remember that notation? Okay. That notation has bothered me since I was 15. Because, what does that mean? Reciprocal. Reciprocal is not inverse. And yet, because they put the reciprocal notation on the function name itself, they call that inverse notation now. I want to find the old dead dude who made that a thing and make him deader. Just, it's bothered me for over 20 years. Ugh. Anyway, it's not going to pass the horizontal line test, so I say that the inverse function does not exist. Okay, a cubic. Now here's the thing about cubics. They can be nice like this, with just a point of inflection in the middle, in which case it would pass a horizontal line test. Or they can have that whole double lump in the middle, in which case they would not pass a horizontal line test. I have no clue. So you type it and tell me which of those two is it. Will it pass or will it not? It's the first one? Okay. Wait. Negative 2. 2, 5. Yeah, it is. Okay.
Yeah, it is the first one.
But then if I split that one up, this is just x minus 2, or x plus, yeah, x minus 2 cubed, isn't it? I think it is. Hi.
What's the last class you have yesterday?
White 4, 28 freshmen for algebra half.
Oh, thanks.
Oh, that sucks that that's your last period.
Yes, it does, because that's a day in which I don't have any break, and by the time I hit the end of the day, I'm on severe overload. Yeah. Thankfully, I have not, like, Hulk Loki smashed any freshmen yet, so. No. It is the first one, and it is x minus 2 cubed. Okay, so I thought, but, head, ow. Like, legit headache. If it's this one, it passes a horizontal line test, right? So then I would say it does have an inverse, and that's it. I would just say, that's it. It exists. Hi.
So, like, for example, the top part would come down and the bottom part would go up, right? Wouldn't it be opposite sides, or how does that work with the horizontal?
Remember, it reflects over the line y equals x. So like this.
Isn't that like diagonal?
Yep. So this would come here, that would go there,
Okay, I think
like this.
I think just using the word horizontal threw me off because I was thinking like this, so I thought it was like that.
Well, the horizontal line test, it'll fail like that. Like this will pass a horizontal line test. This will not.
Okay, the horizontal one is technically like that.
No, horizontal is straight across. The inverse itself is reflected over that. And I'm going to lock the door.
Oh, thank you.
Okay?
Because I had to do that last year when I was in band before I quit.
You have to understand that band rolling around is sensory hell for me. It makes me want to like rip eyelids off. So, band kids, you may go.
I was in band from 6th grade.
But we are locking that door after all of that shenaniganry is over. Then I will open the door.
Wait, are we allowed to take
If you want to watch, you go stand out in the hall. I'm going to keep teaching. Yeah.
No, I don't think I can do that loud.
1A and 1B, get them. Is there an inverse or not?
Taylor, remember when you tore my AC joint? I want to go. That's acting up so bad.
No play tennis sets, please.
Just ask, yes or no. Do they have an inverse? Look, if you want to do the thing, go do the thing. I'm saying I have to protect my peace because our school administration will not.
That didn't even make sense to me that you just said. All I heard is.
Correct. Just yes or no, does it exist? Negative B, 2A, so 5 negative. 5 halves. 25 fourths. Minus. Negative 5 fourths. Yeah. I'm just making sure that I put mine in the right quadrant here. Okay. If I got to that, and I've got to that, you just look at the graph and you say, will this pass a horizontal line test? Now, if I'm looking at that second one, or the first one, sorry. Clear. Clear. Let me say 4 over x, and then we zoom back to standard. Bummer. Now, you can see the curvature of it right now, right? What if I take that window and I take it out further? Negative 50 to 50. And this is where some kids might start to have a little problem. A, that starts to look like a horizontal line, right? But what would happen if you zoomed way in on it? It's got a tiny, tiny curve to it. Like if I zoomed in right here, I would see the axis here and this little curve to it, okay? So it will continue curving because you're taking something and dividing it into smaller and smaller pieces. It's never zero. each piece will consistently get smaller. Another part to point out, look at what changed in the graph from the first time I had it versus the second. You see how now it's just kind of missing pieces? This is something to be very aware of as we do the inverses and as we get into chapter 2 with our rational functions. The calculator won't show holes. We know that because it can't put this pixel and this pixel right on top of not that pixel when it's running a screen from 1995. So what happens when I have an asymptote that it is not supposed to exist on, but I'm supposed to say that it's right next to it? Sometimes the calculator just quits. Look at what happens when I keep this going even further. Nah, it just kind of stops. We have to be smarter than the calculator that this is continuing down. This is continuing up. And it does have a curve to it. We just got to know that it's not showing it because it's too close to the asymptote. And that's going to happen more in the coming weeks. But it does pass that horizontal line test. So, yes, it exists. No, it does not. Cool?
Cool.
Cool.
How do we write that? How do we write it to say yes?
The instructions were just, does it exist, yes or no?
Oh, okay.
Yeah. That's it. Now, the reason we show you that is so when I say, find the inverse of this if it exists, I don't want you to do all the work only to get to the end and wait, this doesn't work. If you had just looked at the original graph and saw that it doesn't pass a horizontal line test, you wouldn't have had to do that work because you know it doesn't exist. Okay? Yeah, you look at the original, and then before you go trying to find an inverse, double check to make sure the inverse even exists by looking for that horizontal line test. Just save yourself the headache if it doesn't work. Okay, there's your steps, pretty easy. Take a look at the original. Will it have inverse or not? Should I even bother doing this? Next, replace f of x with y. They are not the same thing, but they do talk about the same features, so I'm allowed to replace them. Swap x and y, right? Domain and range. If domain and range swap your x and y. Rearrange it so that y is all by its lonesome again. And here we go. I need an inverse of this. First things first, dump it in your calculator. Will it pass a horizontal line test? Should I even do it? Well, do you have it on your screen? Yeah?
I see what you mean.
Now, if you think that that hits at 1, you think it goes horizontal at 1, try this. Go down to 1. Now, do second calculate an intersection between those two graphs. If you think that they intersect, you should be able to do that, and they intersect. Okay. This one should pass the horizontal line test. It has a horizontal asymptote at 1. So just like the last one we did, it'll get really close to 1, but if I zoom in on it, it's still got that little bit of curve to it. Okay, so it does have an inverse. Rewrite. Replacing f of x with y. Then, in order to make an inverse, I swap x and y. I swap my domain and range. I turn this into x equals y minus 1 over y plus 2. And now you got to rearrange that so that y is all by its lonesome.
Yep.
I want to see who can figure it out, who remembers the trick. Because I just went through this trick reviewing with Algebra 2 last week. Oh, it's Algebra 1. I reviewed with Algebra 2. Oh, yeah. Can you get y by itself? Start monkeying with it. Multiply, divide, move some things around, group some terms. Can you get y by itself? I want to see if everyone remembers, quote, the trick before it's actually go time.
As far as I got. And then I gave up that. That's right.
I knew this was.
Hmm?
I knew this was. No, I don't. I just reminded me.
What did you just ask me?
Go nuts.
I had COVID in December, can't smell or taste. That doesn't affect me.
It irritates the nasal cavity. It has nothing to do with your actual sense of smell. However, people won't acknowledge the reality that that loss of sense of smell or taste, that's nerve damage. It's not just, haha, I'm sick. It's, no, your brain was damaged.
And it can be permanent.
Yes, it can.
I haven't had it since December, so it's I always said to my parents that I got brain damage. They didn't.
No, it's legit. It's nerve damage. That's like the nerve endings that go into your nasal cavity are permanently damaged. Well, over time, they might be able to regenerate.
I'm never gonna get it back.
Like I have nerve damage going down into my shoulder and my arm. And over time, that's mostly repaired itself.
So pretty much I'm never getting that back, and I should just say, well, sucks and stuff.
For now.
So,
Okay. If we don't got the thing, I show you the ways of the force. Cross multiply.
definitely already did it wrong.
Cross multiply to begin with. Okay. Now, I know there's a lot of alphabet soup up there, but this is no different right now than y minus 1 is 5y plus 2. How would you solve this? Okay, but here's the deal. When you subtract 5y from both sides,
No, the other Y.
oh, okay. All right, we can do that too. If I subtract y,
You get 4Y.
but how did you get that?
My brain just said it happens.
My brain just said it's 4. What did you do to get the 4? Didn't you technically say 5 minus 1? Why? Okay.
I don't either.
Minus 2, minus 2. What's on the other side? How'd you get that?
I added it.
Didn't you really say negative 1 minus 2?
Everything's addition, but it just has a negative in front of it.
Yeah, for real.
How would I get y by itself?
Divide by 5 minus.
You divide by the 4, which is 5 minus 1. It's just along the way, we kept simplifying because they were like terms, right? You always simplified because they were like terms. Isn't this still negative 3/4, the same as this would have been? I said, I'm making stuff up. I'm showing you that this is the same as that. But because we're so used to combining like terms, we just kind of forget that this is really 5 minus 1 y's. So what's going to happen over here when I subtract y? No. No. If I say large pizza minus small pizza, is that now just medium?
Now it's just
Not even pizza, just medium?
Now it's just Chuck E. Cheese pizza.
Like, y'all, that's now x minus 1 y's.
That was me.
All right.
Yeah, I'm just so
So apparently, we were never taught just distributed principle in terms of combining like terms. Let's try this then. Minus y minus 2x, because I want y stuff on one side, not y stuff on the other, right? Now, if I were to write this out, that goes away, I now have negative 1 minus 2x and xy minus y. Are we okay with that? Because they're not like terms.
we divide by x.
Don't go dividing by x. What do they have in common? They have a y in common. Factor out y. X minus 1 y's. X minus 1 y's. I have that many y's. So you can either factor the y out or just do it on the fly. Either of them work. But now if I have negative 1 minus 2x, y times junk, get y by itself. Divide by junk. Negative, you know what, I'm going to put the x first. Like this. That's it. I can now say that the inverse function of x is negative 2x minus 1 over x minus 1. Yeah, I'll just cross multiply and then factor out the y. Okay. Okay. I do actually review this in algebra, my inclusion algebra, algebra 2, and I usually have to review it here in PreCalc. It's not difficult, it's just we forgot, oh hey, factoring's a thing. Oh, wait.
One of the times my 7th grade sister asked for help on her homework, and I'm like,
Blue.
My brother does that too.
Hey, on this one, it does say to state the restrictions to the domain. Who's not allowed to the party? I want you to pay close attention to the difference in directions.
oh wait.
Thou shalt not divide by 0. Negative 2 wasn't allowed here. In fact, this one had a domain of x can't equal negative 2 and a range of y cannot equal negative 1. Or, sorry, positive 1. So, when I swap domain and range, x and y, I swap domain and range. This one now says x cannot equal 1. Pay attention to the difference in the directions. If it says state the domain, then I have to do this. This is state the domain. This is state the restrictions to the domain. Stating the domain, you actually have to have set builder or interval notation. State the restrictions to the domain just says who's not allowed. So I can just say x doesn't equal 1 and move on. Okay. Try it again. First things first, does it pass? Does it pass a horizontal line test? Yay or nay? Yes. Okay. The graph of this looks Looky like that. And what is this point right here? 4, 0. And from there, it continues off into the wild blue yonder. So just right now, what's the domain and range of the original? What x's are allowed to the party? From 4 to infinity? When I plug in that 4, what do I get? So my range is from 0 to infinity. That means when I go and find the inverse, the domain and range of the original will swap to make the domain and range of the new one. Call this y, swap x and y. Get y by itself. But I have to state at the end that the inverse function of x is x squared plus 4. Now, if I was looking at only that, only the end result, I would think, well, it's parabola, all real numbers. But look at the original. The domain and range will swap. Isn't this translated 4 up? So won't this one have a range of 4 to infinity? So what's the domain of the inverse? 0 to infinity. That's why you would usually see things like such that x is greater than or equal to 0 after these. It's really common that we would see that. Now you can write it in interval notation too. 0 to infinity. I want you to put a note next to these. If you're going to find the domain and range of an inverse, find the domain and range of the original and just swap them. Okay? So if you don't know how to find the domain or range of one or the other, you can just transpose them. Because if I was looking at just this, I wouldn't have known that my domain is only from 0 to infinity. Because, go back to the graphic representation, if I reflect this over the line y equals x to make my inverse, doesn't it look like this? It doesn't have the other side. If it had the other side, it wouldn't be mirrored. It wouldn't be an inverse. So I have to restrict the domain. It's because this had the principal root of a positive square root of x. Hi?
Well, if we're done. No, we're okay.
Oh, no.
We have 4 minutes.
You know what? Just cutting off there. We'll just start with that on Monday. Because we're going to have to review it anyway.
Alright, since we're done. You know what's really ironic? What? Science nerd game is really fun.